Hey, also, like I said, this is 9.4 logarithmic functions. So first, I'm going to start off by sort of explaining what a logarithm is. Now, we'll say that these logarithmic functions are inverses to the exponential functions we graphed the other day. So y'all let me let one in real quick. Alrighty, so this is log, log, short for logarithm. That's a subscript A and then a Y. All right, let me let one in real quick. I got two coming in, okay. All righty, so logarithm, this little subscript A right here, this is what we call the base of the logarithm. And Y is what we call the result. So what this logarithm finds when we use this terminology, it finds exponents. It finds the exponent that the base A was raised to equal the result Y. So the logarithm finds the exponent that the base A, for my example, so it finds the exponent that the base A was raised to equal the result. And my result is the Y, okay? So I'm looking for exponents. How many times was this base multiplied to get these results, okay? So basically, a logarithm in the long run is an exponent, okay? So the thing about this, all right, let me let one in real quick. Y'all must be getting knocked off and on or something. So there's two special logarithms on the front of the calculator. So on the calculator, the log on the front of that calculator right next to the, I think it's the 7. Yeah, the log on front of the calculator right next to the 7. This is a log base 10. So if there's no base shown, it is understood to be a 10. And then you'll notice there's a LN button on there. Now this is a LN, not an I. LN. This is what we call a natural log, and this is a log base E. So the two buttons on the front of the calculator, the log, like I said, is a log base 10. LN is a log base E. If I want to evaluate any other base other than 10 and E, I will show y'all where that is in the math feature on the calculator, okay? So I'm just going to do a few examples here, and then we'll look at a graph. So I want y'all knowing what these logs actually are. So Let me do a log base 3 of 9. So y'all, here's what this is wanting me to find. It wants me to find the exponent. So this is going to find the exponent that the base 3, so since the base is 3, it's going to find the exponent that 3 was raised to equal 9. All right, y'all, let me see what my chat's got going on. Y'all, let me ask y'all this. Are y'all able to hear me?
Yes, sir.
Okay.
Yes.
Okay, so it must be on your end, Jackson. All righty, so what do y'all think? I got a 3 here. 3 to what exponent equals a 9? What do y'all think?
A 2.
A 2. Good job. So when I take the log base 3 of 9 in the long run, that equals 2. So y'all remember, that's what I'm looking for on these. I'm looking for exponents. How about a log? Oh, let me see what's happening here. I just got people getting knocked off and on. All right, y'all, try this one. How about log base 7 of a 1? What exponent? So this is going to find the exponent. Seven was raised to equal 1. So this would be like 7 to some exponent is going to equal 1. So what exponent could I raise any number to equal 1?
Is it a 0 or a 1?
It is a 0. Anything to the 0 power equals 1. So the log base 7 of 1 equals 0. Okay. Now, how about a log base 5 of a 5? So what exponent would I raise 5 to equal 5?
5.
Oh, let's see. 5.
Is it 1?
That'd be, oh, I heard it just now.
1.
1. So if the base matches the result, then that exponent would be a 1, because 5 to the first equals 5. Okay. So just remember, we're looking for the exponents that this base was raised to. How about this one? A log of 100. Oh, I don't have a base shown, so the base has to be what?
0.
Oh no, remember what we said up here?
10.
Yeah, 10, because remember, if there's not a number there on a log, it is actually a 10. So this means what exponent was 10 raised to equal 100? So the exponent 10 got raised to equal 100. So basically, how many times you multiply 10 times itself to equal that 100?
10.
2.
Yeah. Okay. So I just wanted y'all to realize that if there wasn't a base there, that it definitely is a 10 on that, okay? And then that would have been the answer on that one and the answer on that one, okay? All right, so y'all getting the idea now that these are exponents. So let me show you what the graphs will look like. Because they have a sort of certain pattern like the exponential graphs did the other day. So what I'm going to do here, and then the rest I'll graph on my calculator. I just want y'all to sort of see why they got certain shapes, okay? So I'm going to graph log. Well, let me let one more in. Log base 3 of x. So this will be, whoops, I forgot my f of x. So this will be f of x equals log 3 of x. Now, one thing about this, when I make my x and y table to do this, I can't pick a 0 here because there's nothing I can do to any base to turn a number into a 0. So our x's have to be greater than 0, okay? Because I cannot turn any number into a 0, and I can't turn any number into a negative number. So your x has always got to be greater than 0. So the smallest x I'm going to choose is a 1. So if I put a 1 in for the x, what exponent would I raise 3 to get a 1? So what was that'd be a 0. Which means no matter what the base is, if this a 1, then the exponent has to be 0. So that's a little property of these graphs. Remember, the exponentials all went through 0, 1 on the y-axis. Well, these will all go through 1, 0 on the x-axis. All right, so I got a 3 there, so I'm going to pick numbers that I know 3 will turn into. So my next number I'd probably pick is a 9. If I put a 9 in for the x, whoops, I'm going to put a 3 first, my bad. Make that a 3, not a 9. I was trying to skip one. If I put a 3 in for the x, what exponent would I raise 3 to make it a 3?
1.
And that'd be a 1. Now I'll do my 9 because, okay, so if I put a 9 in there, what exponent would we raise 3 to turn it into a 9?
2.
Okay. And that's what I do when I pick my x's. I'm trying to find numbers that are perfect squares of this or multiples of 3. Anything else like 4, well, that would give you a decimal, 5, 6, 7, 8. Those would all give you decimals. So you're trying to find numbers that are perfect squares or cubes or whatever, okay? So now let me show you these graphs. So let's see, my x's went out about 9, so I'm going to go 10 to the right. And then I'll go down. And check this out. I can't pick any of these negative x's because I can't take the log of a negative number. So what's going to happen is these graphs can never cross over the y-axis. So here's my first point, 1, 0. It's right on the x-axis. Then I had 3, 1. So that'll be 1, 2, 3 over and 1 up. Then I had 9, 2. So that'll be over here at 9 and up 2. So they don't climb very fast. Now on this left side, so these will come down. It's going to cross at 1, 0. And then this graph is going to come down. And it makes a horizontal asymptote with that y-axis. So it's almost like a vertical asymptote with the y-axis, okay? Remember, it cannot cross over because you can't take a log of a 0 or a negative number, okay? So remember the exponential graphs yesterday, they sort of went uphill and they was made an asymptote with the x-axis. These make their asymptote with the y-axis. Now, I'm going to show you how to graph these on the calculators. So, notice I got a log base 3 on mine. So let me show you how to get those log bases like that. So y'all, let me share my calculator. Now notice right here on the front, right by the 7 is the log button. So if I had a regular log base 10, that's what I'm using. Then I got the ln by the 4. If I got a log base e, that's the button I'm using. For any other logarithm, y'all, watch this. So I'm going to go to y equals. I need to get the log that lets me put in the bases on it, okay? So you hit the math button, and you're going to scroll down until you find log base. So it's A on mine. Hit enter on that. It brings up the log. I had a base 3, remember, so I'm going to put a 3 in. I'm going to arrow right and put in my x. Okay? So now, and then I'll show you on the table what happens on them zeros and other numbers. But first, let's graph it. We know what we've seen. See, there it's trying to come down to that y-axis. It's hard to tell because of the pixels on the calculator. And then it sort of slowly goes uphill to the right. But y'all, watch this table when I click on second graph. Look at that. I got 0 at 1 for my x's. That's the smallest number I can do. Look, I get an error on any 0 or any negative number is going to give me errors, okay? So that shows you that the smallest x we will choose is a 1 on these, okay? So they're going to give you a couple graphs. So let's do one with the ln of x. So I'm going to go to y equals. I'm going to clear this. Now remember, the ln's on the front of my calculator. So I can hit the ln by the 4 and then put in my x. So remember, this is the base e, that little e we learned about the other day. But look at the graph. It still looks the same. Still makes a asymptote with the y-axis and still slowly goes uphill to the right. Okay? So I want y'all to notice these shapes on these graphs. And they'll give you 4 pictures to choose out of those. And you'll just choose A, B, C, or D. Now, knowing how to do the calculator and find those log bases, that's why I wanted y'all to bring y'all's calculator tonight so y'all can give me some of these answers. And then on some of them, I'll show you the tricks to finding the radicals and something like that. So y'all, for these examples, y'all are going to find the logarithm or the exponent, right? So these will start around number 4. So one of y'all find me this, the log base 6 of 1,296. So y'all good on that, or y'all want me to show y'all this one?
Could you show us?
Alrighty, so remember now, since this ain't a log base 10 or an E, I'm going to go to the math on my calculator. So let me get off the graphing. So I'm going to go to math. We're going to arrow down till we find log base. Once we got log base, hit enter. I had a 6 for the base, so I'm going to put in my 6, arrow right, and then put in my 1,296. So if you notice now, it looks exactly like my problem. Other than the problem don't use parentheses. The calculator uses parentheses just to keep the result there, okay? Now we're going to hit enter, and look at that. We get a 4. So 6 times 6 times 6 times 6 equals 1,296. All right, so now that y'all know how I did that, here y'all go. Log base 8 of 512. So that's on y'all. And I don't see my chat. Where's my chat at?
Is it 3?
It is definitely 3. 8 times 8 is 64. 64 times 8, 512. Good job. How about log base 10 of 1,000? Now let me ask you this. Since that's a log base 10, you can actually use the log button on the front of the calculator, because it's understood to be a log base 10. So you wouldn't have to do the math and do that one if you wanted. You could use the log on the front. Because remember, this one is just like a log of 1,000. All right, so what exponent would you raise 10 to equal 1,000?
3.
There you go. All right, so I'm gonna trick them up a little bit. Watch this one. Log base 3 of 1 over 27. Now, when you got fractions, you're going to notice a special kind of exponent. So what exponent would I raise 3 to make a 1 over 27? And y'all guess what? You can punch that right in your log base. So what am I hearing?
-3.
-3. Good job. Fractions give us negative exponents. Okay. All righty, let me try this one. ln of 1 over e. Remember, the ln is on the front of your calculator. Now, y'all, when y'all do these on MathLab and you got to write ln, use the little l and the n. It'll make it highlighted when you put it in right, okay? If you use an in, it won't highlight it, and that'll let you know that, hey, that needs to be an L. So was y'all able to punch this one in?
Is it -1?
-1, okay. Because remember, the E, you can hit the blue button and the divide button, and it'll pull the little E in there, okay? So on that one, I'll show y'all what I'd have done on that. And I mean, if you wanted to do it quick, you just hit that LN button and then do 1 divided by second divide to get the E, close parentheses, hit enter, and there's that -1, y'all. Okay. So you'll see tonight ain't nothing but really just learning how to punch stuff on the calculator. All right, 9 was a log of 10. So you got to remember, what's the base?
10.
So you got a base of 10, but the result is 10. So there's only one exponent I can put there.
1.
1. So y'all notice anytime your base, they can be hearts. But if the base matches the result, that's always going to equal a 1 on that, okay? All right, let's try this one. Log base 3 of 3 to the 4th. So what exponent would I raise 3 to make it look like a 3 to the 4th? So y'all watch this. Let me show you how I would punch that one in.
Was it 4?
Oh, it is definitely 4. Good job. So I'd start out going to math and getting that log base. Our base was what, a 3? And then our result was a 3 exponent 4. See, all it's in there exactly like it looks. So hit enter, and you're going to get a 4. So if you got a log and the base matches the result raised to an exponent, the answer is always the exponent, okay? All right, y'all, so this one I'll have to show you. Log base 5 of the 7th root of a 5. So this is the 7th root. Now I'm going to show you something on my calculator first. Let me share my calculator. If you hit the math button and you go down to number 4, that one is a cube root. Now look at number 5. Number 5 has the x in front of the radical. So if I got any other root than a cube root or a square root, I'm going to use this link, the one with the x in front of the radical. But the first thing you got to do, you got to give it the index of the radical, which is my 7. So I'm going to quit this screen and show you how I would do number 11. So I'm going to get my log base first by hitting math, arrowing down, whoops, and get my log base. My base was a 5, so I'm putting that in. Now I got to do the 7th root of 5. So since it's the 7th root, you're going to hit the 7 first. Now watch this. When I go to math and I go to number 5 with the x in front of the radical, when I hit enter, look what it did. It made the radical with the index of a 7, and then underneath, I'm just putting in my 5. So remember, anything higher than a cube root, to get that radical, you hit the number or the index first, and then go get the radical with the x. All right, y'all, so watch this. I hit enter. Now, I don't want decimals, so I got to go back to math and turn that into a fraction by hitting enter twice, and it is a 1/7. So, check this out. Radicals always end up as fractional exponents, okay? Because square roots and cube roots are really raising stuff to the 1/7, 1/3, and all that fun stuff. So radicals end up as fractions. All right. How about this? Log of 10 to the -4th. So y'all should be quick on that one now. Because remember, what's that base?
10.
So you got a base that matches the result to an exponent. So the answer is
-4.
-4. No, these ain't too bad once you play with them and get into the idea of what you're actually looking for, okay? All right, what about this? Log 64 of a 4. Look at this. Your base is bigger than the result. So what in the world can I do to a base to make it look like a 4? So y'all push that in and tell me what you get. And remember, if you get a decimal, turn it back into a fraction. Oh, y'all gonna make me punch that in? All right, watch what I get, y'all. I'm gonna go to math, go down to log base, enter. I had a 64. Whoops, I didn't hit enter, I guess. So I had a 64 for my base, but the result was a 4. And check this out. When I hit enter, I'm gonna get a decimal. But I'm going to turn that decimal back into a fraction by hitting math and enter. So you get a 1/3. That means that in order to turn 64 into a 4, you did a cube root of it, okay? Because remember, the fractions represent my roots. So this is saying a cube root of 64 would equal that 4, right? 4 times 4 times 4. All right, y'all. Log base 33 of a 1. All right, y'all should be quick on that one.
Return 65 and get Medicaid.
It is definitely a 0. If there's a 1 in there for that result, y'all better put me a 0 there, okay? All right, so I'm going to sort of skip through some of these. I'm going to do another one like 16. ln of the 9th root of an e. So the 9th root again, so let me show you what I'm going to do. I'm going to hit ln first. Then I'm going to hit 9, and I'm going to go into math and get the one with the x in front of it, okay? All right, let me clear some of this off. So ln is the right by the 4. I need to hit the 9 since my radical's got a 9 in front of it. And then go to math and choose number 5 with the x. Now when I put it back, it shows me a 9th root. I'm going to get the e by hitting second divide. And then I'm going to arrow out and close my, well, I don't even have to close them, but I will. But there you go, ln of the 9th root of e, hit enter, and then turn that into a fraction. Math, enter, and you get a 1/9. So just remember, radicals can be written as fractional exponents, okay? All right, y'all, so then next. Next we're going to learn how to convert from exponential to logarithmic. And this is something you're going to need to know when we start solving equations, okay? And we'll start solving the equations, I think, around next Wednesday. So here's our little property. Log base a of y equals x, and I'm drawing a double arrow here. This means if and only if and only if a to the x equals y. So this is your conversion between logs and exponential. A log of a base a with a result of y equals the exponent if and only if the base raised to the exponent equals my result. Okay? So let's see how y'all do on some of these. We're going to convert to a logarithmic equation. So they're giving us, this one will start around 17. They're giving me 10 squared equals 100. Now we're converting to a log equation, so we got to write log. So the first thing I would ask y'all, what would be the base? Well, the base is the same base as the exponent has. Remember, 10 is my base, so this will be a log base 10. 100 is the result. Well, that's going to go right here where my result goes. And that's going to equal the exponent of a 2. Okay, so y'all with me? Log base 10 of 100 equals 2 is rewriting this exponential as logarithmic. So knowing that, try this one. 1024 to the 1/5 equals 4. So I'm coming over with my log. First thing I need to know is what is the base of my logarithm?
1024.
So that's going to be 1024. Now, y'all, when y'all write these in MathLab, when you write log, it'll highlight it. MathLab will have a little box like that with a blue box. Click that to do the subscripts, okay? Once you put the subscripts, arrow right and come back up even with the log. Now, what's the result I would put here?
Four.
Okay, so then, see, I got to come back up to put my 4, and that's going to equal the exponent of
1/5.
1/5. Okay. All right, let's see what I got here. E to the negative 2 equals M. So here we go. Here's my log. All right, what's the base of the log?
E.
My result?
R.
Yeah.
M. Sorry.
M. And that'll equal the exponent of
-2.
-2. No, these ain't bad. You just gotta remember that the base is the base of the log. The result is the result on the log, and so on, okay? So let's go the other way. We will start with logarithmic, and we will convert them to exponential. And y'all, I want you to get good on these because when we solve equations, we're going to be switching back and forth quite a bit on these. So these will start at 21. Log base 3 of 9 equals 2. So if I'm going to rewrite this as exponential, what's my base?
3.
What would my exponent be?
Mm,
2.
Okay, because remember the log finds the exponent, and 3 squared equals the result of a
9.
9. There you go. And that's true. 3 times 3 is 9, okay? Oh, let me see here. How about log 0.1 equals -1? So remember, you had negative exponents when you had fractions or decimals less than 1, okay? Because remember, 0.1 is the same as 1/10, so it's sort of like a fraction. But I'm wondering what y'all are putting over here. What in the world is your base?
10.
Good job. No base, automatically a 10. Exponent?
-1.
All right, you're on 10 to the -1 equals 0.1. Okay. All right, so I'm going to do one like 24. Log base m of a r equals a -z. Now here's the thing. Math lab, lowercase, got to be lowercase in your answer. Uppercase or capital letters, got to be capital letters in your answer. They got to look the same as the variables we're using, okay? So the base over here. Well, the base is my m, right? The exponent m is raised to would be the -z. And m to the -z equals the result of an r. So this one, they're not giving you numbers and stuff on this 24. They're just giving you letters to see if you know where to put them over here, okay? All right, y'all, so let me play some of these. These will say use a calculator to find the common log. Now, let me tell you this. The common log is the base 10 logs, okay? So that's just going to be our LOGs, okay? So for this 25, they want to know what is the log of 68. Well, guess what? This is a base 10. 10 to the first is 10. 10 squared is 100. So it don't multiply perfectly to get a 68. So when you got a situation like that, we got to approximate these 4 decimal places. So we're going to approximate 4 decimal places. Okay, so if they're not perfect squares or cubes of that base, and you know this is going to be 1 point something, right? Because 68 is in between 10 and 100. So that means the exponent has to be between a 1 and a 2. So y'all, let's punch in a log of 68 and see what we get. And we're going to round that 4 decimal places. So the log button's right on the front. Log, what did I say, 68? All right, there's my log of 68. Hit enter. And see, it's in between 1 and 2. So it is a 1.832. So the 5's in the 4th spot. Got a 0 after it, so I'm going to leave that a 5. So 1.8325. All right, so that would have been my answer. So let's see what y'all get from my 26 here. How about the log of Well, let me see what they got. The log of 167. So y'all find me that and round me out about 4 decimal places. And I will say this, it'll be between 167 is in between 100 and 1,000. So this exponent's got to be in between 2 and 3.
2.2227.
2.222. Yeah, because the 7 has a 1 after it. So good job. That will stay a 7. All right, let me see what y'all do on this number 27 then. Log of a negative 77.
It doesn't exist.
Oh, wow, good job. Because we can't take the log of a negative number. Good job. And they'll actually have a blank that says does not exist on it, okay? I think it looks like choice B on those. Okay, so anytime a log is of a negative number, you automatically put that. That's why that graph didn't go to the left side of that y-axis, okay? All right, y'all, so these next examples say use a calculator to find the natural log. And y'all remember the natural log is the LN. I'm going to put a capital L in there so that y'all realize that's an LN, not an IN, okay? So do this one like number 28. It is a LN of 39. And we can do that with the calculator in the front on it. So y'all punch in LN of 39 and see what we get. All right, let me see if, oh, nothing on my chat or, okay, y'all.
3.6636.
Oh, perfect. 3.6636. Because y'all, this had a 5 and a 6 after it. Since the 6 was bigger than 5, that 5 rounded to a 6. Good job. All right, so y'all, that's the main thing we're doing on these. Here's one, LN 800.7. Punch her in to see what you get. Now, I do know it's going to be bigger than that answer because 800 is a lot bigger than that 39.
Yeah, we are
6.6855.
6, 8, 5. Yeah, because the 4 is the next spot, but it has an 8 after it, which means I round that 4 to a 5. Good job. All right, here's one. This one shouldn't take you too long. LN negative 0.15.
Does not exist.
Oh, does not exist. Good job. But I'm trying to take the LN of a negative number again, okay? All right, so these next few, so for 31 to 34, they say use the change of base. Well, that was old school. Instead of, when we say use change of base, we want you to use the log base that's in the calculator. So remember, go to math, scroll down and find log base. Log base will let you punch them in and the result and give me an answer, okay? So knowing that, now remember, you're going to round these off 4 decimal places. So y'all find me the log base 5 of 70. And round me out 4 decimal places. Okay, so you're going to, oh, did someone get it? So y'all hit math, scroll down and get the log base and put that in as a 5 and a 70. Round me 4 decimal places.
2.6398.
639. Well, that 7 had a 3 behind it. So since the 3 wasn't 5 or greater, we're going to leave that one a 7. Now, y'all want me to show y'all a trick on rounding these off so that you don't have to guess what these are rounding up or not? Watch this. I'm going to go to my calculator. I'm going to teach you something else about this calculator. You see this mode. When I hit mode, and I go down where it says float, that means it's floating the decimal. If I go over here to 4 and highlight 4 and hit enter, my calculator's now going to round me 4 decimal places. Watch this. Look at this answer I got a while ago, 1.832508.9. When I hit enter, it rounds it off to 0.8325. What did we just have? We had a log. Let me go get log base. Log base. I had a 5 and then a 70. Now watch when I hit enter, it's going to round me those 4 decimal places. Now here's the thing. When you get out of this homework, put that back on float by going to your mode and putting it back on float and enter. That way it won't mess up stuff in the future, okay? But if you want it to help you round it, put it on 4 for now, do your homework, and then you can switch it back. Alrighty, y'all. So let me see. The last little bit of this section is having us do a graph. So this will be like 35. Now, what they want me to graph, they want me to graph both functions. And then you'll pick a graph that has your 2 functions on it, okay? So they're giving me f of x equals 5 to the x. So I got one that's exponential. And then the inverse, remember the inverse notation. That's what that f negative 1 is. The inverse will be the log, which will be log base 5 of x. But y'all, I'll tell you the truth. Watch this. We know what the exponential graphs do. Remember, they cross at 1 on the y-axis. They sort of hug the x, come up through 0, 1, and turn up. That's the exponential. We learned today what the logs do. The logs are going to cross over here at 1, 0. They're going to hug the y-axis, remember, and then they're going to go slowly up to the right. Y'all look at that picture we just drew. There's only one of these 4 pictures doing that, and that's this A. See how you got your red line coming up like my exponential? And then here would be my logarithmic. But officially, We can graph that, right? So let's go to our calculator. I'm gonna go to y equals. So let me make sure I'm back on float. Okay. So I'm gonna go to y equals. In y1, I'm going to put the first one, which was 5 exponent x. Then I'm going to arrow down to y2. That one was log base 5 of x. So remember, I got to hit math to get that log with the base. Go down to log base. Hit enter. My base was a 5. My result was the x. So we got them both in now. So now I'm going to hit graph. So y'all, there went that first line and then that second one. So y'all, that's the world of logarithms. Just remember in log run, a logarithm is basically an exponent. Okay. So, y'all, it's a lot of calculator work tonight. Not really much to do by hand. I mean, you can play with some of them in the beginning, but when you get to the ones where it's wanting you to estimate, those are pretty impossible to do by hand anyway. So use the logs and LNs on that calculator, okay? So y'all, questions on your logarithms? All right, let me quit my recording here.